All right. So Wente, now you think now's a good time to start?
Yep.
Okay, thank you so much. All right, welcome everybody to our first of 2025 Truck Regulation Implementation or TRIG group meeting that focuses on infrastructure. This is the sixth meeting altogether, but the first one in 2025. Today we're going to be talking about on-site generation and microgrids. But before we go to the agenda, I just want to welcome some of our new panelists. And go to the next slide, Isaac. Because we did a panel refresh for this year. Back in December, we released a notice about updating the infrastructure TRIG panel, and that notice included a survey for those interested in staying on the panel or joining the panel. We received responses from over 70 people from different stakeholder groups, and we selected about half of them. The panel members shown on this slide represent a lot of stakeholders. That includes large, small, and public fleets, truck manufacturers and dealerships, industry, trade, labor, environment, and health-based groups, interest groups, electrical and gas utilities, charging and hydrogen station developers, and state agencies and local air districts. And you'll see that we have a new co-chair. Lisa McGee is going to be co-chairing this with me, as well as Kate Reed from the California Energy Commission. So before we get started, I want to give you an update on advanced clean fleets. You can go to the next slide when you're ready, Isaac. So as most of you are aware, California has withdrawn its request for a waiver and for authorization to add the ACF regulation to its emissions control program. Today, CARB is evaluating next steps, but we're not enforcing existing provisions of the ACF regulation that require a federal waiver or authorization, and that means high priority and drayage fleets. The state and local government fleets portion of the ACF regulation, which does not require a federal waiver or authorization, remains in effect. But because CARB is committed to reducing air pollution to protect public health, we encourage affected industries to continue reducing their emissions, and we look forward to continued partnerships in these efforts. So let's go on to this meeting. And today we're going to be focusing on the role that on-site electricity generation plays in supporting battery electric truck fleets, both as an interim solution while a fleet is waiting for grid connection and energization, as well as for backup power and other uses. While there are a number of zero-emission temporary charging solutions available or being developed, they either do not provide enough power or prolonged power supply needed by larger trucking fleets, or the technologies are just cost prohibitive. Linear generators came to our attention a few years ago as a means of generating electricity on location with emissions significantly lower than any combustion generator on the market. Today, we're going to hear from Mainspring and Hyliion about their linear generation technologies, and also from Zeem Solutions about their commercial charging sites and projects involving the demonstration of mobile batteries and a methanol fuel cell generator. Next, South Coast AQMD will talk about their Rule 1110.3 governing the permitting and source testing requirements for linear generators. And CARB will follow that with our analysis of the strengths, weaknesses, and opportunities of on-site grid power generation solutions. After that, representatives from the larger electrical utilities will share their perspectives on the use of these technologies. And the rest of the meeting is going to be dedicated to clarifying questions and focused discussion. At the end, I'll be asking our panelists and our audience members to offer suggestions on topics to discuss at future infrastructure TRIG meetings. So I want you to just keep that in mind and jot them down in the chat, or just chime in at the conclusion of the meeting. So now I'm going to introduce each speaker, but before I do, this entire slide deck, along with the recording of this meeting, is going to be posted on the ACF meetings and events calendar for this February 10th meeting, and that'll be a few weeks. And then afterwards, we're going to be going through all of the presentations first, and then take those clarifying questions at the end. And if a question comes to mind during the presentation, please just use the Q&A feature. Our panelists will be able to raise their hands, but they can use the Q&A feature as well. And then also for the folks who are presenting today, if a question comes in that's sort of specific to you, feel free to answer it in the chat and the Q&A feature, but just know that we will also be curating questions to ask our panelists as well. So let's move on to our first presenter of the day. This is Anders Thulin from Mainspring Energy, and Anders is the transportation sector lead at Mainstream Energy. So you are up first. Take it away, Anders.
Perfect. Thank you, Leslie. Hello, everyone. As Leslie said, I'm Anders Thulin. I'm responsible for transportation sector at Mainspring Energy. Just very quickly, Mainspring has been around since 2010. Spent the first 10 years in the process of R&D, really, and then in 2019 went commercial. So since 2019, we have a lot of projects installed for various applications. I'm primarily responsible for the transportation sector, but obviously we're not the only sector that has a need for on-site power generation. What I want to cover today, if you go to the next page, if you could please, Leslie, is why are we here? Why do we think that on-site power generation is necessary, very valuable and important in the EV context specifically? What type of solutions exist in the marketplace that may or may not be relevant and optimal for the purposes of EV? We'll dive a little bit more into on the technology. I want to show you a use case, a project. To give you a hint, the picture on the right there is a picture from a site in Los Angeles where there are 96 Class A trucks that can go through that facility. It does not have any grid tie connection today. It's in DWP territory. Very exciting project. I'll share more details about here in a moment. And then some key takeaways or considerations for you or your partners to consider as you're thinking about whether or not on-site power generation is a good fit. Next page, please. So first, I think a lot of people in the room already know this. The chart on the left, what you see is a 5-year energy forecast for the United States holistically. I know this is a more or less a California discussion today, but the challenges of power are certainly not unique to California. In 2022, the 5-year forecast for power needs reached about 23 gigawatt in expectation. But just 2 years later, that's increased 5-fold to 128 gigawatts that are anticipated to be needed. This is a historic growth in power demand, where power demand for the past 20 to 40 years has been around 1% growth year on year, on average in the United States. And that's now increased so significantly that, of course, this is going to create some challenges for our utility partners to work through. But if you go to the next page, specifically what it means, of course, is that cost may go up, energy costs may go up, and that's because we need new generation, we need new transmission, we need new distribution. All those systems have to be upgraded. We also have to think about emissions from grid sources. We can't just use dirtier peaker power plants from 20 years ago. So not only is it new load that has to be considered, but also replacement of older load in order to clean up our grid. And some of the measures that we're taking in order to make the grid of the future stronger and cleaner includes deploying assets that are inherently not constant. So you look at things like solar and wind. There are times when there's no wind and there's no sun, obviously. And so reliability is also a key concern, a challenge for the overall grid construct to consider. And then finally, I think something that a lot of you can relate to is speed. How quickly are we able to get some of this new capacity online? It's not just the capacity, it very much comes down to the availability of things like medium voltage gear, as an example, with lead times from your major suppliers today upwards of 2+ years. So oftentimes when we look at deploying EVs, especially at heavy duty trucking facilities that need a lot of power, and oftentimes in areas that are already fairly grid constrained, those timelines may just be very difficult to manage and not particularly conducive to the strategy of deploying quickly. So we believe, if you'll turn to the next page, that on-site power generation is a critical asset to support the build-out and the responsiveness of the grid in this context. And we really want to think about the availability of different on-site power generation technologies more or less in two buckets. One is a performance-based bucket. How responsive is the technology to the load profile of an EV fleet? A load profile of an EV fleet is desperately different from a cold storage plant or a data center with a constant load demand. So we think about flexibility in terms of variability of demand throughout a day is paramount in an EV context. And some of the technologies that exist in the market today are really restricted in terms of their potential output, deviating from an 80% or from a 50% and down below type of demand up to 100%, ramping up and down dynamically as vehicles come and go. So that's on the sort of y-axis that you can see on the page here. And then on the x-axis, to think about combustion versus non-combustion. What's the emissions of this solution? Are we just taking a combustion engine away from the wheels and putting it into a stationary application? Or are we really making a sort of end-to-end significant improvement on the overall emissions profile, which at the end of the day is, of course, CARB's overall objective with the whole endeavor to move towards EV? So when you look at sort of the best of breed in our perspective, you want to be able to have a system that is flexible, to be dynamically following the specific load of an EV, and one that is non-combustion. And that's where linear generators come into play, that are able to ramp quickly to a full range of output with low emissions that fall within the requirements of the AQMDs, and also critically be able to switch between various fuel sources as those fuel sources become more cost competitive. If you go to the next page, please. So specifically, a linear generator from Mainspring, again, several deployments throughout the country, heavily in California because it is a tool that's been used both for reducing cost of projects and also tying together with other grid assets or DERs. The solution is a 250 kW 20-foot ISO container, 483 phase AC power out per unit. It's scalable up to 25 megawatts per acre to meet specific load requirements. It can switch dynamically between any gaseous fuel, and not only from one to the other, but also blends of fuel. So if you envision starting with natural gas, eventually run on hydrogen to be zero CO2, then there's a method to do that by blending and increasing volumes of H2 as you go. And that also enables projects to start now, because running on hydrogen today for EV fleets may be not cost competitive. Projects we have in the ground today are both grid parallel, in other words, working together with the grid, solar assets, but also those that are completely islanded from the grid, again, as a tool to be there until the grid is able to arrive. I think critically for this conversation, I know there are some AQ&D partners on the call as well, is the emissions profile. And I'll get into the more technicalities of the how, but suffice it to say for this page that the emissions profile of Mainspring's linear generator running on natural gas, you're looking at less than 1.5 parts per million on NOx, or for those of you thinking about megawatt hours, 0.04 pounds per megawatt hour. And of course, when you think about greenhouse gases from a CO2 perspective, far less than what you see from combustion technology. And then of course, when you're running on a fuel like ammonia or hydrogen, you're looking at zero CO2. A final point, which is important, I think, a lot of the technologies that exist in distributed generation today may be large tools. Think about a 5 megawatt turbine or 10 megawatt turbine. If you break something inside that machine, you could be looking at outages for the full project for months on end. Here, with a 250 kW package and that distributed architecture, you could look at impact of doing service on one unit, not having any nominal real impact on the availability of power for your fleet charging. If you go to the next page, please. So just briefly, so that everybody gets sort of familiar with the idea of the technology and how it works, what you see inside that 250 kW package are two what we call linear generator cores. And what's happening here is you have two oscillators moving into a center reaction zone. That inside that reaction zone, you have a combination of air and some gas that gets compressed to the point at which molecules break down. Those molecules then release energy in the form of heat. That heat then pushes the oscillators out, and they run through these air bearings, which is just cushions of air. If you can think of an air hockey table in a cylindrical fashion, run through copper coil configuration with magnets on board to generate electricity, and then bounce air on the outside in these air springs, and then come back in for another reaction. And this is happening 12 times per second. So it's a very fast moving machine. And so essentially the key thing to consider here in that center reaction zone is that you don't have sparks, you don't have a flame. So you don't have combustion in the way where in a combustion machine, because of that flame reaction, you have these hot pockets. And those hot pockets can exceed 2,500 degrees Celsius, creating significant NOx formations. Here, everything stays below 1,500 degrees C in homogeneous temperature reaction. So you don't have hot pockets, so you can stay below 1,500 C, and you can therefore avoid those NOx emissions from forming. The other thing to consider, of course, is the efficiency of the system. You're seeing two moving parts that takes chemical energy in the middle, immediately transfers to mechanical energy through movement to electrical energy. So you don't have a lot of spinning components that drive down the efficiency of a machine. And if you think about cost of a product, you think about capital cost, operating cost, O&M, and you think about efficiency, cost of fuel. So few parts, lower O&M, greater efficiency because you don't have efficiency losses throughout the machine, greater efficiency. And then obviously what happens in the middle here is you're crunching fuel. Different fuels have different energy density. So depending on what fuel you're sending into the machine, you may have different movement of the oscillators as they move in because they're controlled by power electronics that are exactly matching where those oscillators should be 1,500 times per second. I think if we turn to the next page, what this means and what this has meant in terms of project contents is one, this is a project with Prologis and Maersk performance team in LADWP. Unfortunately, they needed to get this going. Prologis, Maersk is a Danish company. They have specific objectives when it comes to emissions. So they may not have been as impacted by ACF regulations, more of corporate governance perspective, to really drive EV as quickly as possible. Here they needed approximately 10 megawatts of power. Unfortunately, it was going to be a few years from the utility until they were able to get that. So what they ended up doing was using 3 megawatts of mainspring linear generators paired together with 6 megawatts or 18 megawatt hours of batteries. Again, we think about high ramping type of project demand. You can pair those two types of assets together that make sense in concert in that particular context. And what this enables them to do is to get power a lot quicker. So prime power now, when the utility eventually arrives, you can either peak hour shave, use as a backup asset, or of course, introduce some sort of alternative fuel, such as hydrogen, in order to sort of further clean up and support Los Angeles' objectives of deploying hydrogen. And then, of course, from a speed perspective, rather than wait 3+ years for the utility to arrive in this context, the project was able to be up and running in 12 months. Very last page, if I could, please. So think about, our view is think about deploying on-site power generation not as a means to solve one end, but a means to solve multiple ends over time. So first, you're deploying on-site power generation, in our case, linear generators, to get the project going as quickly as makes sense for your strategy. When then the utility arrives, in theory, you're solving for on-site power generation because the utility is not there. You have optionality. You can deploy us as a peak hour shaver. You can double the capacity of a project and increase the charging speed of your chargers because now you have more power, or you can use us as a backup. Remember, the classic backup technology, diesel generation, just doesn't make sense long term from an emissions perspective. And then in phase 3, or even in phase 2, if you want to put it there, in phase 3, really thinking about how can we make this even better? So the technology is available now. You can deploy it now with natural gas. When it makes sense to do so, you can switch to an alternative fuel. So final page, key takeaway. Dispatchable DER is a critical component of all this. And we can do it without sacrificing emissions. That has to be the case. And frankly, a lot of technology has been deployed successfully. So it's not like you're having to start over with something and have to be the first of its kind with pilots. You can do projects now today at scale. And I think critically, thinking about DERs not as something that is just for one thing, but you can really use it as a tool for a lot of different purposes. So I'll turn to the final page. And thank you for your time. Thank you, Leslie.
All right. Hey, Isaac, move on to the next slide. And I want to introduce Bobby Cherian. Bobby is the Senior Vice President of Government Affairs at Hyliion. Take it away, Bobby.
All right. Thank you, Leslie. Hello, everyone. My name is Bobby Cherian. Anders, I have to thank you because you hit a lot of the key things that we'll be talking about here as well. Our technologies are both linear generators. We execute a little bit differently, but a lot of the things that Anders had just spoken about are similar to what we'll see with Hyliion technologies as well. So if we go to the next slide, please. We are just coming up to market with our linear generator. So I'm going to spend a little bit more time talking about who we are, our technology, and I won't try and repeat everything Anders had said, but maybe I'll spend a little bit of time talking about some of the differences. So we're Austin, Texas and Cincinnati, Ohio in terms of the company. We actually acquired this technology from GE. They had called it Carno. It is a linear generator, and the company, you may know us previously creating a range extender heavy duty truck. We've kind of put a pin in that application. We had that actually all the way ready to go, and then we decided to pause and spend all of our efforts now on this Carno generator and bringing this to market. And now we are right around the corner for the first units going out the door. If we go to the next slide, please. Okay. Thinking about the linear generator, I think we're still having a little bit of trouble, Leslie, with the animation. Is that correct on this one? If we click another time here.
I could not get the animation to work. I'm sorry.
Okay. Oh, there you go. It's working. There we go.
Oh, hallelujah.
Yeah, we'll take that one. So you'll see in the slide, we have one moving part in each of these individual cylinders. We actually pair 4 of them together to get 200 kilowatts of power in our initial launch application. What we do is very different, though, in terms of generator technology. We are using, again, any fuel that can generate heat. And on the outside ends of the generator is where we actually draw in the fuel air mixture. We spark that one time, and our goal is only to extract the heat from that reaction. So any of you that know Stirling engines or heat engines, that's really all we're trying to do is we're trying to draw the heat out of the ends of the generator. And in yellow there, you'll see a heat exchanger. So the only thing we're doing there is drawing the heat into now the red area that's sitting around the piston. That is actually a trapped volume of helium. So as that helium starts to expand, it shuttles the piston to the right. The exact opposite reaction is happening on the other side of the generator, where again, we're just heating up a trapped volume of helium. That piston is moving back and forth roughly 20 times per second. So it's really flying by. In the middle, we have very similarly copper coils and wires that are just kind of sitting there and then producing the electricity as that shuttles back and forth. If we go to the next slide, please. And click one more time for me. And I'll just hit on some of the benefits of the generator. So we are completely fuel agnostic, and I will share with you the list of fuels that we've already tested on the next slide. When I say fuel agnostic, we use not only gaseous, but also liquid fuels as well. And as long as the fuel can produce heat, we can run it through the generator successfully. ultra low emissions, less than 4 ppm across the broad spectrum of fuels. That will change somewhat if fuels are contaminated, for example, as we're using Permian Basin flare gas, for example, coming out of the oil fields. Our ppms can get into the 11 or so range for NOx, but it's still extremely low even when we have contaminated fuels. Our efficiencies are at 50%, low maintenance, so we only have that single moving part in each of the shafts, so 4 in our 200 kilowatt assembly. Very quiet as well, less than 67 decibels at 7 feet. And we can go from a complete black start capability with this system as well. If we go to the next slide. Just quickly, just touching on this one, you'll see the different forms of fuels that we've already tested here, different forms of natural gas, different forms of hydrogen, conventional fuels, and also some alternatives and some really interesting ones like ammonia that can also be used to produce electricity with the generator. If we go to the next slide. From an application perspective, we have a lot of options, and I'll talk a little bit more in later slides about why. But EV charging is going to be one of our first applications out of the gate this year. A couple of customers using it in 2 different types of applications, one in heavy duty trucks, one in other applications for EVs. Data centers have a very big pull as well. We all know some of the challenges that they're facing today with power. Waste gas is going to be an interesting place for us. We see 2 applications in this one. I already mentioned that we're doing some work in the Permian Basin using flare gas coming off of oil fields. We'll do similar with landfill gas as well. Prime power is really where the technology shines. So we have various applications around that. And because we have some really unique characteristics around footprint and size, defense applications also are really interesting for this generator. We actually do have a contract with the Navy to put these power systems into unmanned vessels for the Navy today. If we go to the next slide. So the fascinating part about the generator is that we actually do a lot of the components internally, make all the components internally, I should say, within our facility using additive manufacturing or 3D printing. So you'll see on the left-hand side of the page, that's actually one of the parts that goes into the system. You couldn't do this with traditional manufacturing processes, and this is what allows us to get the really high levels of efficiencies and really disconnecting the reaction of the fuel from the rest of the power system as well by using really intricate heat exchangers such as this. If you ever have a chance to come out to our facility, you'll see some of these 3D printers that we have in operation. Go to the next slide, please. So I wanted to quickly just share with you, I've got 2 more slides, this one and one more after it, just what our footprint looks like as we think about power here in the future. So we're going to launch on the left-hand side of the page the 200 kilowatt system. You'll see it's roughly 8.5 feet tall, 8.5 feet wide, 2.5 feet in depth, so it's very power dense. When you look at the middle application, the 2 megawatt solution, this is what we're targeting for data centers and other high power users. You can fit that into roughly a 20-foot shipping container type of space, so it's very power dense. But the beauty of the system is you can customize the power, package it any way that you need to, just by stacking additional power units together. So we can get really creative with how we do this for customers in different power sizes. If we go to the next slide, just quickly, just a quick view of what the systems will actually look like. The 200 kilowatt there you see on the left, which is again our launch product, and on the right, the 2 megawatt solution, again, fitting roughly in a 20-foot shipping container. That is my last slide. I wanted to just give you a quick intro to the company and what we're doing, and I appreciate all of your time. Thank you.
Thank you so much, Bobby. Okay, our next presentation is coming from Tom Gage from Zeem Solutions. Tom is Zeem's Senior Vice President of Energy Technology. Take it away, Tom.
Thanks, Leslie. I'm Tom Gage. I'm Head of Energy Technology at Zeem Solutions. Go ahead and go to the next slide, please. Zeem is an operator and developer of charging depots for fleet electric vehicles. So we're really more of a consumer of the kinds of technology we're talking about today, as opposed to a developer or a manufacturer. And with We've been in business since 2017, but have only had an operational depot over the past 2 years or so. We have 2 sites near Los Angeles Airport, LAX, where we charge fleet vehicles using power from the grid. We had a good year in 2024. We actually achieved profitability at our sites based on variable costs. We're well funded, but our funders really are interested in seeing profitability as soon as we can achieve it. So we're under quite a few business constraints in terms of how we operate our depots. We limit ourselves to shared use or dedicated sites for customers under contract, so we don't do opportunity charging at all. And the 2 sites we have both near LAX, and we expect to add 3 more this year in New Jersey, Seattle, and Savannah, Georgia. We focus on areas near ports to try to get the best location for many of the port shipping operations. We've talked to thousands and thousands of fleets over the years as we developed our business plan and understand, we think, what the barriers to EV adoption by fleets are in many cases. They include the high cost of equivalent facilities versus diesel refueling, insufficient power at sites, cost and time for grid upgrades, and uncertainty in terms of regulations, economics, and technology. So our current sites have excess grid power available, but many of the sites of our customers do not, or sites where we might locate depots close to customer activity sometimes have almost no power at all. So we're looking at off-grid solutions, including mobile and stationary batteries and on-site generation. We also understand that high utilization of assets is very important to our business model. So that's one aspect that we take into consideration. Next slide, please. This is a load curve for a day last month at our site, one of the sites near LAX, and you can see that we dispensed 22,000 kilowatt hours that day. The peak power was 2.4 megawatts. The average was only 925 kilowatts. So you can see how, I can't say this is a typical day. It varies quite a bit from day to day. We do try to pay attention to hourly rates, time of use rates, but we can't always accommodate and minimize use during the high cost periods of time. Next slide, please. So the objectives of anything that we look for in terms of off-grid on-site power are, first of all, the power we need to charge the vehicles. We're interested in fast setup. We don't want to own property for a long period of time before we can start generating revenue. That helps if it's temporary, because we do understand that eventually the grid will come to the site and we'll want to move the equipment to another site. The fleet operators, especially because of the uncertainty in this business, are looking for low or no CapEx in any solution they want to install. They don't know what to install. They don't know exactly where to install it, or even if the site they're using will be suitable in the long run. They are often willing to accept somewhat higher cost compared to just the standard electricity rate, but it still has to be acceptable. Small on-site footprint, everybody wants that. And of course, the most important in some ways is the regulatory compliance. It certainly has to be cleaner than a diesel or a gasoline fueled vehicle. Ideally, it's cleaner than the grid if possible. So we're actively looking at two technologies to provide off-grid on-site power. One is a mobile battery. We've done a demonstration in December. And the other is the Kaizen Clean Energy methanol fuel cell generator. And I'll talk about both of those next. Next slide, please. We like the idea of mobile batteries for one reason. Most of our sites that we're building now actually have excess power, which means we have more power than we can easily dispense in the footprint we have under our control. So that means we have excess power that we can use elsewhere if we can get it there. But as we've discussed, the grid, it's not just a generation capacity, it's a constraint on the distribution of that energy. And with fleet vehicles, the demand is high and it's very localized. So many of the sites will require some kind of a distribution power upgrade to really service the fleets as they evolve. But with the mobile battery, what we demonstrated was we rented two 1.2 megawatt hour mobile batteries. These were built on a custom, almost 30-foot long trailer. They were within the road weight limit as towed. I think the whole vehicle was about 71,000 pounds. And these batteries were fully self-contained with power conversion from the battery voltage to 40 volt AC, along with a fully self-contained thermal management system. We operate these batteries in pairs so that one charges while the other discharges, and then we swap positions. And in this demonstration, the charging site was at LAX, and the discharging site, or where we charged vehicles, was about 20 miles away in Wilmington, California. We could have done as much as 3 cycles a day for each battery, so we would have been able to deliver about 7,000 kilowatt hours per day. Next slide. One of the most impressive aspects of this demonstration was that we got it up and running in one day. At the power hub, which was our site near LAX, all we had to do was drop a 300 kilowatt skid-mounted transformer and hook it into a circuit that we had available that was powering level 2 chargers, which we almost never used. So we had a transfer switch that would allow us to take that power, run it through the transformer, and into the mobile battery. Next slide. At the Wilmington site, we had to drop another transformer. We also had to drop a skid-mounted remote control switchgear, and we towed in 3 175 kilowatt DC fast chargers mounted on trailers. Then with the Nomad batteries hooked up, we were able to start charging Class 8 tractors there the same day. So literally it was a one-day setup from nothing, from a bare lot there to charging tractors. Next slide. The Kaizen Clean Energy methanol fuel cell generator is a technology we've been studying or working with for almost 2 years. It is basically a fuel cell generator that runs off of hydrogen that's converted from methanol. So methanol, a liquid fuel, is delivered by trucks. A proprietary reformer is used to convert the methanol into hydrogen gas. The hydrogen gas is stored in a low pressure vessel and is then used to power an off-the-shelf fuel cell. The electricity is stored in a 96 kilowatt hour battery and then is used to power 1 or 2 DC fast chargers. Next slide. This is a picture of what the Kaizen system will look like. This is a 2nd generation version that is basically contained in 3 20-foot containers. One is the methanol fuel cell generator. One is a thermal management system that can be mounted on top of the fuel cell generator. And the third is a methanol fuel storage tank. The output is about 150 kilowatt hours continuous, and it can load follow or charge stationary batteries when not charging vehicles. The one pictured here is a prototype. There's an earlier prototype that's been in use for about 2 years. It's been torture tested as the source of electricity to power a fleet of electric racing SUVs competing under the Extreme E contest. So it's fairly well tested in very arduous conditions. These races took place all over the world in isolated areas. So it can pass that test. We're interested in, we're working with AQMD fund a demonstration of this unit so that we can better understand the logistics of handling the methanol fuel, the efficiency, and the operating cost in actual use. Next slide. I remember a project when I was in college where we converted a car to methanol, and it had many purported advantages. We didn't achieve those. In fact, we had a car that generated a lot of I forget what it was, but it came out of the exhaust pipe. It stung your eyes pretty badly. Formaldehyde, that's what it was. But actually, methanol does have some significant fuel advantages. One is that it eliminates the need to transport high pressure hydrogen. It's much easier that way. And so we generate the hydrogen on site. According to Kaizen, methanol is the lowest cost H2 carrier. And I should mention that at the site, the methanol is mixed with about 20% deionized water, which adds hydrogen to the mixture and optimizes the operation. Methanol is a safe fuel, flammability and combustibility like diesel, water soluble, easy to extinguish a methanol fire. It's a liquid, not a gas. And methanol is readily available, globally produced, widely distributed in Los Angeles is a green methanol corridor. Methanol fuel generates 0 NOx and SOx and particulates, and its carbon intensity is dependent on how methanol is produced. Next slide. In summary, Zeem believes off-grid power is necessary to accelerate fleet electrifications, and we're looking for solutions that are scalable, convenient, versatile, transportable, and easy to implement and finance. And so anything that can meet all those criteria we like. Charging economics are difficult. We go by the understanding that diesel fuel refueling is about 100 times faster than battery charging. And so diesel infrastructure is not a good model for EV charging. It requires a different approach from both the fleet operators and the fueling or energy providers. Utility and PUC participation and adaptation are necessary over the long term to meet the needs of electric fleet charging, and we think off-grid power may help spur the necessary changes. Thank you.
All right, thank you so much, Tom. Our next presenter is Hei Lo. Hei is an air quality specialist at South Coast AQMD who will be talking today about the Air District's Rule 1110.3 on emissions from linear generators.
Thank you, Leslie. Yes, once again, my name is Hei, air quality specialist at South Coast AQMD, here to go over Rule 1110.3. Next slide, please. So just a quick background on how we got here with the regulation. In 2019, during the amendment to Rule 1110.2, which is emissions from gaseous and liquid fuel engines, we were informed of linear generators. You guys heard that from Anders during that introduction there. And during that time, the emissions were incorporated into 1110.2. However, you guys again have heard the unique operating characteristics of the technology. And so we decided it was a good idea to develop a rule specifically for the technology, for the considerations of it. And as a result, going through the rigorous and robust rule development process, public rule development process, Rule 1110.3, emissions from linear generators was adopted by our South Coast Board in November of 2023. And the regulation has specific limits for linear generators, as well as other provisions, including source testing, monitoring, reporting, and record keeping. Next slide, please. So again, back to those unique characteristics. It's nice to follow the manufacturers. They've done a lot of this already to introduce it, but basically you guys have seen how magnets are driven through copper coils in a linear motion, and that produces electricity, hence linear generators. You guys have also heard about the low emissions profiles of this technology. Low temperature, low reaction temperatures result in low emissions. They typically don't have any type of after treatment devices needed to meet those emissions, such as catalyst heating. And so, you know, they also have pretty fast startup times. Next slide, please. So diving into the rule here, the applicability of the rule during the the rule development process, as you guys have also heard, this rule is specifically applies towards natural gas-fired units. As you guys again have heard, that these are fuel agnostic technology that can run on various fuels, but Rule 1110.3 specifically applies to this technology on natural gas fire, on natural gas, excuse me. You guys have also seen the variety of applications and engineering behind this. And one important thing we had to do in this rule is to define the linear generator unit. And so after a lot of discussion, we've defined a unit in the rule as a single core, and that's how the emissions are going to apply. Now, diving into the emissions limits themselves, we looked at source testing data, source testing results. And based on that, you see here in table 1, the concentration limits for linear generators, basically 2.5 ppm for NOx, 12 ppm CO, and 10 ppm for VOC. Next slide, please. So on that note of NOx emissions, we looked at comparison to other rules such as South Coast Rule 1135 for NOx, and the emissions limits mirror those in that regulation. The NOx emissions also meets CARB's distributed generation certification program limits, and so just a comparison as far as electricity generation technologies goes. Next slide, please. So source testing is a big, very crucial part of the regulation, and it's the way we ensure compliance with the rule limits here. And more specifically in Rule 1110.3, source testing is required to be conducted once every 5 years. In addition, as you guys have heard, multiple units are being deployed to sites, and so those facilities that are operating 6 or more units at a single facility have the option for pool testing. And then that pool testing is also required to be conducted. Source testing is every 3 years. And the requirements for the source testing need to be conducted based on the methods spelled in table 2 there for those pollutants that you see in the table. Next slide, please. In addition to the source test, we have other requirements, as you guys can imagine, maintenance requirements, inspections based on the manufacturer's recommendations. And monitoring is also important, monitoring to verify emissions compliance. That's going to be required to be conducted every 2 years. And all of the associated record keeping and reporting along with that to verify compliance. Next slide, please. So moving right on to the current applications and what we're seeing within our South Coast Air Basin. Again, peak power, prime power and peak shaving, just as you've heard from the presenters previously. Microgrids, they're used for situations where grid power isn't readily available, and so they're being put in as kind of a bridge solution to provide the power for EV charging trucks. Next slide, please. Now, what we envision moving forward as far as potential applications, you've also heard that also, this technology is a great transplant for backup power, such as applications in hospitals and other healthcare facilities, as well as data centers, and potentially other emergency applications. Next slide, please. And other future plans and considerations, again, we like to explore the fuel agnostic capabilities. There's a lot of potential there for a reduction in emissions, such as hydrogen fuel technology. It was also mentioned that methane could be used as well as other renewable fuels. So as an agency, we're definitely interested in learning more about that. Given the infancy of the technology, we're really curious about the durability and robustness of this technology. So we're going to continue to keep an eye on the performance of this technology over a period of time and kind of see what the life expectancy is of this technology. Right now, Rule 1110.3 only covers the 3 criteria pollutants, but we're also interested in learning more of the other potential emissions that might be coming from this technology, more specifically looking at particulate matter and toxic air contaminants. And finally, as we start to learn more about the fuel characteristics and durability, we are definitely considering any potential update to the rule that might have different emissions limits for the different fuels, because remember, Rule 1110.3 is specific to natural gas-fired units only. And so, that's definitely a consideration. In addition, we have a certification program that we are trying to develop for this technology. Working with stakeholders, we felt like there's potential there for developing a certification that would streamline the process and that would help expedite and get this technology out there where it's most needed. And next slide, please. That concludes my presentation, and I didn't mention previously, but I also have with me from South Coast Isabel Shine, who is a program supervisor, as well as Mike Morris, planning rules manager, who has joined us for this presentation. You also have a link there on the bottom right to the rule in case you guys need to download that. Thank you, guys.
Thank you so much, Hay. And then just all of these links will be live on the version of the presentations that we post online. Miriam is our final presenter today. Miriam Delavarafi is an air resources engineer with CARB's small but mighty zero emission infrastructure team. I'm gonna let her get going on her presentation now. Thank you, Miriam.
Thank you, Leslie. Hello, everyone. Good afternoon. Miriam Delavarafi here within the Zero Emission Vehicle Infrastructure team at CARB. I'm presenting on behalf of our team on the topic of off-grid power generation solutions for medium and heavy-duty vehicle charging. We've heard a lot of great points and insight today from our presenter about on-site generators. So I'll be building off what has been discussed in my SWOT analysis. Next slide, please. Okay, so as you know here, everyone knows medium and heavy duty battery electric vehicles are being deployed in California, and compared to light duty vehicles, more power is needed to charge medium and heavy duty battery electric vehicles. As a result, some fleets require extensive electrical grid upgrades before they can connect to grid, and the expected timelines for grid connection may conflict with their project goals. So to address this challenge, as we heard in other presentation today previously, fleets are seeking interim solutions like integrating on-site generators to quickly provide power for charging electric fleets. Next slide, please. So the scope of my presentation today focuses on on-site off-grid power generation using non-zero emission generators. And the objective here is to perform a SWOT analysis. A SWOT analysis is basically conducted here to provide an overview of implementing on-site off-grid power generation solutions, helping fleets considering these solutions make informed decision. Next slide. So here is an overview of the full SWOT analysis. The slide is a little overwhelming, so we have done this SWOT analysis to evaluate the strengths, weaknesses, opportunities, and threats associated with integrating on-site solutions. Now, I want to walk you through each quadrant separately, starting with the first one, strengths. So the first quadrant is a strength of using on-site generators. On-site generators offer several advantages, as also discussed in previous presentation. These bridging solutions speed up access to electrical service, increase resiliency, and provide a reliable backup power, which can help reduce costs during peak utility rate periods. So this solution also provide flexibility in selecting fuels or technology. Like technologies presented today, they are fuel agnostic. And also you can switch basically from one fuel to another. But I wanted to highlight here that the permitting rules may not have been adopted for that specific fuel type. For example, as he presented in his presentation, the South Coast AQMD Rule 1110.3 only applies to linear generators running on natural gas. Also, additionally, on-site generation solution can be leveraged in remote locations where electricity is limited or unavailable. However, the caveat of these solutions for remote location is that transporting fuel to remote location may present additional challenge as well. So that was the strength of the integrating on-site generators. And the next slide focuses on the weaknesses of some weaknesses of these solutions. Currently, there is lack of robust data for estimating emission rates of different generators. As he presented, now particularly for analyzing particulate matter or PM emission rates and toxic air contaminants, there are not enough data. So this data gap presents a challenge in accurately estimating the environmental impacts of different generators, especially newer technology. So additional testing should be conducted to better characterize emissions and durability of these new technologies. Another challenge is permitting. So these on-site generators are stationary sources with localized emissions impact, and they have to complete all necessary permitting steps with their local air districts. So developer may account for permitting timelines because some local permitting rules, especially for new technologies, may not have been established. Once permitting is granted, compliance verification is needed throughout the period that these on-site generators are in use. To monitor how emissions profile change over time, air districts may require regular source testing for on-site generators, as he presented, similar to the South Coast AQMD Rule 1110.3 requires source testing every 5 years. The next slide is on the opportunity. So what are the opportunities? These solutions provide opportunity to foster collaboration between government entities, private business, and end users. So this collaboration should be expanded to facilitate the permitting process for on-site generators. So air districts, local authorities, also they could establish new local permitting rules for emerging technologies, and they may implement more stringent emission standards because California grid continues to become cleaner over time with the goal of being carbon-free by 2045. So this would ensure that no additional emissions are produced by utilizing non-zero emission generators instead of connecting to the grid. Another opportunity here is that this non-zero emission generator can provide a pathway for utilizing and integrating with renewable electricity generation. For example, they can be integrated with battery energy storage system, as it has been shown in one of the sites for largest mobility sites as well. Another opportunity is that the on-site generators can offer solutions for facilities that generate renewable natural gas or biogases, helping to avoid or reduce carbon dioxide emissions. So the generated renewable natural gas or biogases by these facilities can be utilized by on-site generators. The next slide and the last one, the last quadrant is threats, the potential threats associated with implementing this solution. Non-zero emissions, they can have environmental consequences, including localized emission impacts, because they are not carbon-free, they are not emission-free resources, so they have environmental consequences. And local communities, they may express concern about emissions from this generator, as well as other potential issues. Such as noise could be a concern, fire risk, and fuel storage. But these concerns can be mitigated through an open and effective communication between project proponents, between authorities having jurisdiction, and community members. So it is important to engage with the local communities early in the planning process when considering installation of on-site generator near residential areas. Another challenge, the last one, is the lifetime permitting for these generators. So air districts may require renewal of permits on a regular basis to ensure expected emission performance, or may consider limiting the hours of operation and basically conditions under which these devices are allowed to operate. So lifetime permitting, that's another could be another thread here. So that slide concludes the SWOT analysis and my presentation. Thank you, and I'll hand the floor to Leslie. Over to Leslie.
Thank you so much, Miriam. Okay, so that concludes our presentations with slides. So we can, let's go to the next slide, and I'd like to bring up, if she's ready. Oops, didn't remove that one. Sorry. Here we go. No, go ahead, Isaac. Next one. We're getting utility perspectives now. Maria Soria from Southern California Edison is here today, and I'm wanting. Basically, we're just asking the utilities to just chime in on their perspectives, where they see this technology going, and I will be posting these links into the chat with various utilities, TE advisory services, while our folks are talking. So do we have Maria ready to chime in verbally?
I'm here, Leslie. Good afternoon.
Great.
So one is just start off by saying it's really exciting to see the development of this technology in the renewable generation space. From a utility perspective, we really look at projects to ensure that they meet the applicable tariff and technical requirements to ensure a safe, reliable connection to the grid. So we would need details such as, is this isolated operations? Is it parallel operations? I think in regards to the possible applications, the presenters pretty much covered all of it. So appreciate your time. I really don't have much to add other than this is very exciting. And Leslie, you're on mute.
Eric, are you ready to share?
Sure. Yeah. I agree with Maria. These are technologies that we've been evaluating for our own purposes for different use cases as well, and we think it's an important piece of the puzzle. It's one solution that can be part of a broader portfolio of solutions to help customers with interim power needs. They also have applications for the grid side as well that we've been evaluating as well, from microgrids to remote grid applications and the rest as well. So we're excited to be testing them in a variety of applications, and we're thinking through ways that we can best support our customers in kind of evaluating different interim power solutions, of which linear generators, are one potential solution. So, I mean, the high level thoughts, that's basically it. We also have other solutions to help this use case as well, including technology solutions, flexible interconnection agreements, and other pilots that we're also trying to kind of build out our portfolio of offerings to help customers when there are delays in getting a grid connection. So happy to kind of address any further questions, but that's kind of how we're thinking about it right now.
Thank you so much. Next, we have Scott Moon from Los Angeles Department of Water and Power.
Thank you for the opportunity to comment on this and for putting this meeting together. I think Maria and Eric said it pretty well. I don't think I have too much to add to what they mentioned. We just ask customers to collaborate with our service planning staff and keep the communication going with those folks so that they can get you so that they can get folks what they need. They'll so that they can review the plans and ensure everything's up to par with our electric service requirements. And one last thing that I'll just add is that we're governed by our city charter, and that contains language about DWP being the sole provider for electricity in our service territories. And so I think that's all I have to add. Thank you again for the opportunity to comment on this.
And then thank you so much, Scott. Finally, we have Danielle Wiseman from San Diego Gas and Electric.
Hi, yeah, thank you. I think learning about the new technologies is all very interesting, and it's hard to keep up with, advancements in the industry. But at the end of the day, from a utility perspective, we're here to enable the customer and what they want to do. And each customer, each project is going to be unique. There's a lot of options. I know it's overwhelming probably for fleet owners and operators to navigate this space right now because they're not used to having to be experts in energy. They have base business that they need to operate. That's why we have the advisory services program. I know for the investor-owned utilities, we each have an advisory services program, and I think that's perfect for technology solutions that come up like this, so we can help the customer meet them where they are in their needs. And so if linear generator or any other technology is the way they want to go, how they want to scale or phase out their ICE vehicles and transition to electric or any other solution technology that's viable for them, we can provide them guidance. But at the end of the day, from the utility perspective, I think what we're looking at is safety primarily. What are their operational needs? What do they want to do? And what's the impact to the grid so that we can plan load service and generation interconnection safe and reliable and doesn't have any negative impacts to the grid. So definitely any generation that a customer is installing goes through our tariffs, our Rule 21 interconnection tariff or WDAT, depending on how they want to interconnect. And so that tariff exists for safety, so we can look at their operational needs, study it, understand any constraints on the grid. So I think talking to the utility early, it sounds cliche at this point because we always say it, but definitely come to the utility early with questions, with what you want to do so that we can help give you guidance and, measure twice, cut once. By the time you want to submit a request for service for the load side or for interconnection on the generation side, the more you understand about your options and what the processes and requirements are, the smoother it'll go. So yeah, thank you.
All right, thank you so much, Danielle. And I feel like we're going to put an exclamation point on what you had just said about connecting the utility early and often. And this linear generators or just any kind of on-site generation technology for the purpose of transportation electrification adds a new dimension to the solution of getting power to the site. So that will continue to be our mantra. Now we're going to move on to clarifying questions. And so we've been getting a number of, and maybe Isaac, this would be a good time to stop the screen share so that I can see more faces. And we can make sure that we are, that I can see raised hands as they come up. And we do have another co-chair to this group. Like I was going to call on Lisa McGee first because what the heck, I want to basically introduce yourself as our co-chair and a longtime vocal member of this TRIG. But also I'm sure you have questions. If you can unmute.
Yeah, hi everyone. Thank you, Leslie, and welcome everybody. Yeah, this is an excellent topic and certainly brings to the heart of one of the biggest pain points that we have in this industry is ensuring that the fleets, when they want to buy these trucks, they can actually have a source of fuel. And these lead times associated with utilities is very, 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 very tough. It almost doesn't matter where you're at, even if there's capacity. So this is a great topic. So I do have questions. I'm going to start with Mainsprings. You talked about it's a tool as to helping, I guess, eliminate waiting for the grid. So when you say that, I'm kind of curious, what is the timeline to deliver this? Is it under a year, over a year? And if it's over a year, can you expand on what you envision as a short-term solution for your equipment?
Sure. Thanks, Lisa. Good to see you again. So first of all, you manufacture equipment. So everything we do is built to order, typically around 9-month manufacturing timeline. Honestly, that's not typically the longest pole in the tent, though. You have other elements associated with developing a project, of course, that may be longer lead times. If you think about things like air permitting, for example, I think South Coast has been tremendously impressive in terms of their lead times for doing air permits. Other AQMDs maybe take longer time. Like everyone's been talking about, fairly new technology, so you have to go through a little bit longer of a process to do the validation and verification in the process for that. But then you have other lead time elements as well. You know, low voltage gear is still a piece of a component that's needed for a project like ours that our customers are doing. So all those things come together. The fastest project we saw in an EV space that we've done is that roughly 12-month, 10 to 12-month project in the Prologis 96 Class 8 Truck 1. And then in terms of what can we do to make things go faster, how could we really get, things going faster for deployment of power? There are other programs that CARB is representing that enable sort of a more temporary play type of a solution. Those are potential tools to draw on from a regulatory perspective. Of course, what a lot of industry players are doing now, and I think Tom from Zeem was demonstrating some of the sort of skid mounting applications that you can do, so you're not spending a lot of time underground doing construction work. The challenge with that approach, of course, is it's not a long-term play. If you want an AHJ, it's going to permit your project long-term, then you really got to go through the process correctly, which requires you to spend a little bit more time up front to deploy the project in a way that makes sense for a long-term application. Hope that answers, Lisa.
Yeah, no, that's helpful. I have another question for any of the utilities. I want to understand the interconnection process, since these can create long lead times as well. So I want to just make sure that, are any of these solutions, in the utility's opinion, whether it's short-term, in the future, or a pilot project through the CPUC, do you see any registration required with the demand response registration system and or the proxy demand resource? I just want to kind of make sure that we're understanding some of the requirements the utilities may have, because you did bring up tariff and interconnection. So yeah, I would love to hear back from you guys.
I can sort of help with that. Our requirements are really limited to, like, for on-site generation, the requirements are focused around interconnecting a generator, something that can export to the grid that's operating in parallel with the grid. We need to review it for safety and reliability. So that's sort of one process. Once you have that interconnection, the customer has the ability to participate in different programs or services that include demand response, ELRP, if you want to export to the grid at all, or participate in some of those services to get compensated for the generation, that sort of stands separately. So the first step in the process is really going through the interconnection and understanding, what are your operations? If you have on-site generation and you intend to be able to export, then we need to study it for export. As opposed to, like, some customers may choose to island or have something completely sort of microgrid at their property if they have a single premise. So that it really depends. So the process really starts with the interconnection, and then from there, and part of the due diligence from a financial perspective is probably identifying what some of those programs and services are, so you can understand, does the scope of the project pencil out from an operations perspective, using the generation on site to serve load, as opposed to participating in something like demand response or export or anything like that.
I'd like to Yeah, great. And I would kind of like to add to Lisa's question, because they bring up a really good point, Danielle, when the other utilities are able to respond to this, like, what are you seeing people that want to also interconnect to the grid with these types of solutions? Or are we really thinking about a completely islanded solution? Because that's literally where my brain's been on this technology. It comes to play to provide power to a site, period. It is without, it's not part of the intent to export it. But that is a question.
Oh, sorry, that may be a good point of clarification, because if the intent is really to island, you know, I don't work in the interconnection team, but I can speak to this at a high level. Really, we're focused, if the intent is really to island or microgrid, and you're
from the perspective of fleets wanting to use these vehicles to charge their trucks. Yes.
So
yes.
if you have on-site generation that is strictly to serve load, and you can island that equipment, or it's non-export, you know, that's how we would study it. It would certainly make the interconnection process a lot simpler if it's entirely for non-export. It's just to serve on-site load, then obviously that would minimize the impact, the load impact to the grid. So the study process would be simpler from that perspective. But I don't know, I've sucked up a lot there, so maybe the other utilities have some thoughts. And I see Jesse Denver has his hand up as well.
Yeah, I was curious though, if before we go to Jesse, if any other utilities have some thoughts on this conversation about.
Nothing much more to add from what Danielle added, but in what we've seen thus far, they've mostly been non-export configurations, which make it simpler. And you know, I can speak more detail nuts and bolts of our process, but I mean, the perspective of Anders, others, you know, suppliers working through our process as well might be helpful for folks' benefit on here. And also just we're open-minded about how those processes can be best evolved to better support these sorts of solutions, and that'd be a conversation that we would invite.
Okay. Well, Lisa, I feel like I cut you off, but we'll just move over to Jesse.
I was going to say something very similar to Eric. You know, I'd love to hear Anders and the other industry reps' perspective, because I don't think that's the perspective that I've kind of had around the use case of this technology, as being a sole microgrid that doesn't interconnect to the transmission grid at all. You know, in the case of the LADWP project, the project developers are working with a local utility for their natural gas, and LADWP does have a relationship there where they will start to serve power at that site. So while right now the project is not taking power from that site, that is not necessarily the long-term plan. And, you know, in California, we don't have a flat rate. Every cost the utility has to recover comes volumetrically. So more megawatts on the grid drives down rates, you know, drives that downward pressure on consumers across all kind of sector categories. And so we want to see megawatts on the grid. And at the same time, we need to acknowledge that the utilities do have timelines that can be 4-7 years out. And so, you know, there is that push-pull with how do you get trucks on the road sooner? And that means that we do need these bridging technologies. So one, I'd like to hear from the technology providers on their perspective on this. That way it kind of dispels any myths and or supports the notion that, you know, you are aiming for microgrids that are island or not. Two, my question was, you know, in a scenario like your partnership with LADWP, Anders, you know, when you meet that like 6-year threshold and the utility is able to get you the power you need, are you easily able to move those assets that you've put in the ground to another site? Or do you plan to keep those assets on site to do new things with them that can help support the grid and or provide some sort of on-site resiliency? So that's where I'll stop for right there.
Yeah,
Thanks, Leslie.
You're welcome.
If I may, I think your question about, we need megawatts on the grid, and what do you do with the assets once the grid has showed up? I think those are very closely tied together. But first, to clarify the interconnection discussion, I want to make sure we distinguish between two different types here. We're talking about, are you completely islanded, no grid connection? Are you tied to the grid and running in parallel with the grid? And then thirdly, are you on the grid and delivering power to the grid? And that second and third one is hugely different from one another. And I agree entirely with Daniela. If you want to go through the process of feeding the grid, that's going to be a much longer process. You're going to have to make sure that you're compliant with a lot of regulations in California, especially about how to do that to be compliant with the IOUs. Most of our projects are interconnected with the grid, meaning they run in parallel with the grid. You have solar, you have linear generators, and you have the grid, as an example, in a lot of cold storage projects. Eventually, on a project like the Denker Prologis project, that will be interconnected with the grid per DWP requirements. But what's important is that you're deploying technology that is able to operate without the grid. And that's important for two reasons. One, that's the whole point, right? Is to get a project going faster. And if the grid's not there to be there as your paralleling asset, you need to be able to operate without it until the point at which the grid arrives. And two, once the grid has arrived, we do, of course, have circumstances where the grid goes out, rolling blackouts, or there's an upstream substation issue or whatever it might be. And then, of course, you've deployed this asset. Wouldn't it be great to not have to buy a diesel gen in order to be your backup solution, but to use the tool that you had pre-interconnection as now your much lower emission backup solution? So I think that's why it's important to be able to do that black start capability. But interconnection, we think, is very valuable. Eventually, this type of technology, even if it's owned by a customer, should be considered essentially a grid asset. And that, I think, gets to the second point about megawatts on the grid. We want more load on the grid. The more load, the lower the rates. That makes a ton of sense. And we also have those peak times where everybody turns on their dryers between 5 p.m. and 9 p.m. And rates at that point, especially for fleet operators, can go up to 3, 4x what they are off peak. During that time, now you've potentially got an arbitrage tool that allows you to run at a lower cost per kilowatt hour to make those EV projects more financially feasible. And so you basically have now a 3-step solution of speed, and now backup, and now cost reduction for peak power. And by running during those peak hours, you could potentially also help, of course, the utilities not have to make the generation investments in order to handle those super peaks. So really think it's a grid plus. But to Jesse's question, yes, you can move the assets if you choose to. I can't speak to what Prologis or Maersk will do specifically with that project. The idea is they have a technology that's flexible enough that they can choose by working together with a utility to figure out what makes most sense for that particular use case. Switch to alternative fuels, run backup, move it to a different location. It's their prerogative.
And Jesse, it's Bobby Cherian from Hyliion. Just to add to what Andrews had said, pretty much everything's the same. If you get a chance to come out to one of our facilities here in Cincinnati, we actually have a grid connect. Right now, we worked very closely with the utility, made sure we were doing everything the right way. Absolutely can be done, just like the mainspring system can as well. Our systems will be, when we think about customer applications, will be both islanded, and we'll have some mobile applications as well. So we can absolutely move these around.
Thank you so much. I just wanted to respond to a question that has come in to the chat about literally any questions that are coming in regarding the advanced clean fleets or any move that we are moving forward on advanced clean fleets. We're still definitely in a we're figuring it out mode, but if you do have specific questions, I noticed some coming in from Sam. please email them to Zev Fleet because I am certainly not the source to respond to questions, and that is the channel that people are where questions from. So the email is ZEV Fleet, FLEET, at arb.ca.gov. And so I guess I can just put that in, or maybe I'll have one of my team members put the Zev Fleet email into the chat or the Q&A feature, please, so that everybody can see that. Eric.
Yeah, just a quick question. I saw a little bit in the chat thread regarding this, but might be helpful for folks' benefit. If Anders, you or others can kind of discuss a bit more, especially as people are kind of thinking about the permanence or portability of these solutions. Yeah, what like the roadmap looks like, or the offerings out there currently for like energy as a service or leased models for these, since, you know, to many folks it might seem like they would be ripe for that sort of you know, business model or business offering, especially if folks are kind of thinking about or initially thinking about these things as an, you know, an interim or temporary solution.
Yeah, I suppose I'll take a stab at that one first. Yeah, I think there's different degrees of permanence that could be considered. And what I mean by that is a project, you know, container. You put it down, mount it, and then run underground cabling, and then you can unmount it and put it back of a flatbed and move it to a new location. So technically doable. You can also skid mount them. You could also, in theory, put them on wheels. I think the challenge is not so much a technical challenge. I think it's more about an economic question. By going to a new location, you now start, you know, EPC all over again for that new location. You now start the permitting process all over again. And to be clear, this is not a thing that you can just go and do. There's a permitting process that does take time. And we're lucky in that it kind of matches the time to manufacture oftentimes. But generally speaking, that means that you as an operator need to be having sort of a minimum of a year outlook of your plan. When you get power, you know you're going to get power in a year from the utility, and you know you want to move the assets to a new location. You know that about 365 days in advance. So you're going to start thinking about where they're going to go and go through the permitting process for that type of move. But ultimately, it comes down to money. Is it financially viable to do that EPC again? Or is it better to leave those assets in place and think about a backup solution? I think if you start from the point of temporary exclusively and keep things on wheels or on a skid, I think then you bump into what I was sort of hinting at before with like AHJ compliance about you've limited your flexibility if you made it a temporary asset by design at the start, because now maybe you can't leave it there as a backup asset because you'll be non-compliant with the city code. So I would start permanent, honestly, if you can, and then think about movability based on economics and time.
And if I could add to that as well. So Eric, we have customers that are looking at electricity as a service, putting this on a mobile application, and running it in different places as power is needed. We've had some customers talk to us about, hey, the short-term requirement, like you had mentioned, where power may not be available today, but it will be available tomorrow. And so they've created business models around that and being able to provide energy as needed. And when it's done, you wheel it off to the next location. So we have seen customers look at models like that as well.
I wanted to add to something Anders said, and I thank you, Anders. You described the different types of interconnections very well. There is a difference in operating completely isolated from the grid. That is a break before make connection. The review for that type of application is minimal because we just ensure that you truly are isolated from the grid. Now, the non-export option where you are operating parallel, maybe not always exporting, but you are in parallel to the grid, that is site specific. So if you are planning to move this equipment, you know, this mobility aspect of it, it is important to communicate that to the utility because we will need to evaluate that generation at every point that you may want to move it. And there will be an agreement for whatever duration you're wanting to move the asset to. So just keep that in mind, you know, and I think, again, Andrews, thank you for saying you want to think about these things in advance. You want to start communicating that to the utility. You don't want to do it at the last minute and then, you know, be stuck frustrated because it's not moving as quickly as you wanted. So I just wanted to add that in regards to this, you know, mobile capability of the equipment.
Thank you, Marie. I'd like Mike to ask his question from AQMD.
Thanks. There was some discussion about opportunities for cost savings as for peak shaving. Roughly, what's the cost per kilowatt hour for these technologies?
All the suppliers are quiet.
I know,
Yeah.
and tell us your assumptions. Thank you.
Right. Yeah, exactly. I think so. First of all, grid prices in California on average in a EV project, and I think that's an important comparative metric, is basically when are you deploying power or when are you using power versus when the grid's at what price. So what I've found is that roughly what the grid price is on average that my customers are exposed to is roughly averaged out at 30 cents per kilowatt hour. And our customers who are operating grid power much higher prices than that. And there are those that are operating slightly lower prices than that. But that's generally where we are. And so when you take any of these technologies that are being considered in discussion today, and you take a very minimal O&M cost, and you add that to a cost of fuel in, for example, SoCal Gas, you're going to come in far south of that 30 cents per kilowatt hour. So if your blended average is 30 cents per kilowatt hour, but your on-peak price is, say, 50 cents per kilowatt hour, which some of you are familiar with, then the potential impact cost savings is greater than 50% during those times. Lisa's got her hands up.
Lisa?
Oh, yeah, thank you. It's helpful. And I wanted to go back to AQMD's remarks on the mobile use and maybe even the affordability. And I want to kind of understand, and I'm going to go to Zeems. You had a very interesting, very, very good opportunity when it comes to a short-term solution. And I'm kind of curious about a couple things. On your actual use case that you have at your site in Los Angeles, you gave us a graph of, and I know you expressed that it isn't necessarily consistent, but you've done a pretty good job of eliminating the opportunity charging. What I want to understand in that use case, is there any medium heavy duty trucks, and how many medium heavy duty trucks are in that use case? And then when I look at your 2 use cases that you've been doing with the battery storage versus the Kaizen, really interesting. You said 3,500 kilowatt hours a day in the Kaizen. I don't know if I'm saying this right. And then the battery storage, I think you said 7,000 kilowatt hours a day. So super interesting. I would like to just get your perspective on the continuous use and the runtime on that daily, and the average kilowatt hours.
Okay. Both of those are preliminary numbers based on early stages of the technology. We're looking at what the increment of cost over our price of electricity from the grid is using the batteries, and taking in all of the CapEx and all of the OpEx and the losses in going into the battery and back out again. We think it's somewhere in the 10 to 20 cents per kilowatt hour basis. So again, it depends what we're paying for the electricity and what the market rate is for EV truck charging. But for many of our prospective customers, that kind of number is very attractive because it zeroes out their CapEx altogether. And they say, well, we'll just use this as long as we need to until we get a good connection. And in some cases, they may want to continue using it until they really have a certainty about what their electric vehicle plans are going to be. I think the whole issue with the ACF has raised that level of uncertainty quite a bit. So the fleets are even now more reluctant to invest in charging infrastructure in our experience. I think what was the other question? The Kaizen. We want to understand that better. They're saying that the cost of methanol is very attractive. We don't have any experience with that. But again, this unit competes with the linear generators in a sense, and it's, you know, the big difference is the linear generators, I believe they need a gas feed on the site. If they don't have a big enough gas feed, then there'd have to be some construction. They can perhaps use tanked gas. I'm not sure if that's viable for them or not, but with methanol, it's a simple tank truck operation. And you can store as much fuel on site as you need to, or you can just order these containers of fuel and have them dropped on site. And I forget, was there one other question?
On the battery storage solution, so one of the things I look at for fleets and sites that are running trucks and looking at, you know, I do look at it twofold on the utility side, just to kind of try to think this full circle through. I do see a strong need for a short-term solution, certainly, but I also see a very strong need for peak time shaving and peak time, a 4-hour window or 2-hour window, something to that effect that really drives down the cost and the grid constraints that could maybe create a more sustainable grid all around, especially in urban dense populated areas. And when you talk about these big trucks that need 350 kilowatts just to dispense, they need to be on the road. They don't need to be derated. So I'm just trying to think this through, and you've got a short-term solution, and I'm assuming you guys have taken advantage of peak shaving. So I just kind of would like to just, if you kind of share a little about that experience, and if you see that as a nice sweet spot for the big truck use.
Yeah, we do. A lot of our customers charge their trucks. A lot of our customers right now are ride share. So they have a totally different operating schedule than a fleet truck. And a lot of our fleet trucks are able to charge overnight outside of the peak time of use rates. But I think getting around demand charge, or not demand charges, time of use peaks, you can have a stationary battery or you can use a mobile battery for that, either one, but it involves charging during lower rate usage periods and then discharging it when the rates are high. And in some ways that conflicts with the general approach that we're taking, which is to use all of our equipment 24 hours a day if needed. That way you get the maximum throughput and the maximum contribution to paying down the capital expense. So I think the one area where we're mildly optimistic is that battery cost and battery life cycle time, the cost is going down and the life cycles are going up. So the cost per lifetime kilowatt hour throughput of batteries is going down quite a bit and quite rapidly. So the lower that cost gets, the easier it will be to use batteries in standby applications as well as continuous use applications.
Thank you.
Thank you so much. I think there's one question that came in from the chat, and it's regarding state and local government fleets. It's actually a very long question, but it brings up a super important side discussion that we really want to have at another date, at a later date. And so I am going to grab that question and circle back with our team that is really starting to focus a lot more closely on the challenges faced by state and local fleets, because they are somewhat unique, you know, different from drayage, different from high priority fleets. So just know that this is something that we are looking at internally, and I do appreciate this input very much. But I want to just move on to our discussion today on linear generators. Colin, you have your hand raised, because I did want to move on to a focused discussion, because I did want to talk about potential funding programs, if there are any, for linear generators, and just kind of give people a heads up on that. But go ahead, Colin.
Yeah, I guess just a short background. Colin with Range Energy. We're putting electric powertrains on trailers for refrigeration and dry van applications. So a little different than electric trucks. The background for my question, the conversations and presentations about the linear generators are pretty interesting for ideas to give to our potential customers on how they might expand charging at their facilities. I guess part of it was more so just understanding the application. We're largely trying to piggyback off of fleets that chose to invest in shore power infrastructure because we are planning to do level 2 3-phase charging as our recommendation to have low cost charging infrastructure for fleets and to have less spiky loads for the grid as a great big simplification to a lot of different problems. And so it was just kind of confirming that these applications of these linear generators would potentially serve as, ways of bridging interconnect gaps or bringing up the power capacity of those facilities, kind of thing.
Agreed. Okay, so Isaac, could you put up the slide that has the focus discussion on it? Yeah, thank you so much. I wanted to just these are the questions, folks, just look at them, talk, consider which ones you would like to speak to. But on the very first one, are there funding opportunities to support the deployment and the use of non-zero emission electricity generation solutions? I just want to let you know from the CARB perspective, we do have the CORE program. That's a clean off-road equipment voucher program that's similar to our HVIP program. And at this time, we do not have any on-site power or generation solutions that are emissions-based. Right now, our catalog is entirely zero-emission on-site generators. So asking and answering the question for CARB, but I'm curious if there's anybody else who is on this call right now who knows of another potential program, because yes, Miriam.
Leslie, yes, yeah, I can add, as you mentioned, the CORE program, the current equipments that are eligible are mobile power unit, which is lithium-ion battery storage and fuel cell technologies only. But I want to actually add that Carl Moyer program, which is a program that replaces older, like heavy-duty diesel vehicles with electric, alternative fuel, or cleaner diesel technology. So that is one of the funding resources maybe for the non-zero technologies. The 2024 Carl Moyer program guidelines, chapter 10, focuses on the infrastructure. And in that guideline, the eligible projects are portable power, like including on-site, off-grid power generation, microgrid, mobile refuelers, and portable infrastructure. But any projects that produce emissions, like non-zero emissions technology or near zero emission technologies, must be approved by CARB on a case-by-case basis. So CARB basically will evaluate those projects that use innovative near zero emission technology. So if you want, I can put the link to the guidelines in the chat. And if you have any question, you may want to contact CARB Moyer staff for further guidance on these case-by-case projects.
Thank you so much, Miriam. And then that would also apply to contact their air districts as well, because the air districts like South Coast.
Yeah, I was going to say, thank you, Miriam.
Go ahead.
That's basically what, the Carl Moyer program here at South Coast AQMD also expanded to include infrastructure projects as well. So as Miriam said, the guidelines are spelled out. And if you guys have any questions about that, feel free to reach out and we can get you guys going on that.
Thank you so much for chiming in. I appreciate that, Miriam. Kate, or someone from the from Energy Commission, are you aware of any programs?
Yeah, I can answer that one, Leslie. So at the Energy Commission, I think we're working really hard to balance both getting infrastructure in the ground and operating as quickly as possible with zero emission technologies. So we have been allowing technologies like linear generators to count towards match in our projects. So under our solicitations like critical paths, which focused on medium and heavy duty highway corridors, and some of our other charging projects, charging and hydrogen refueling projects, we have allowed for those linear generators as match. We have, though, been working closely in collaboration with CARB, so there are some things that we require if they're being used. So there's some specific data requirements that we ask for, and then we do ask that the fuel be zero emissions. So, or excuse me, that it be renewable. So whether it's renewable hydrogen or renewable natural gas, we do ask that that fuel be used. But we have been allowing that, and we've also been listening to feedback and analyzing the data. So, of course, it's been a great discussion today. I've been listening, and of course, if there's other feedback in terms of our CEC solicitations, we're definitely open to that feedback.
Okay, before Jesse, just a follow-up question. When you say that so linear generators can count as match funding on a project application, is that a 100% renewable fuel requirement?
At this time, we do have a 100% renewable fuel requirement.
Okay, that's today. Okay, thank you so much. Jesse.
Thanks, Leslie. I just wanted to ask, during LCFS kind of reform in the fall, I know that there was a push to have LCFS allowance for book and claim access to green hydrogen to electricity pathways and linear generators. Now that they're also RPS eligible, could fall in that. Where did that land in the end with CARB under the LCFS program? Because that also is a pathway to funding.
Good question, Jesse. I don't have an answer. I am not I cannot answer questions on behalf of the LCFS team. Does anybody else have any questions or want to maybe bring up any of the points on this focus discussion? I think we covered a lot really well in the question and answer. I was very impressed with the conversations going on back and forth with the utilities and the various utility programs. I feel so much more enlightened. One of the things, and this could actually play into one of the things that we have been hearing from our utility partners on pilot programs that are exploring flexible interconnect. And just so that everybody's on the same page, Eric said that he would jump online real quick and describe what flexible interconnect means. I think the IOUs have all been given the okay to run flexible interconnect pilot programs. But do you have a minute to just briefly explain that?
Sure, yeah, and I think to answer the question on the slide here, I mean it can be complementary to customer generation as well. It's our Flex Connect pilot. It's a bridge to wires pilot, essentially using advanced technology that's been enabled by our upgraded DERM system that allows us to give variable limits to a customer on a day-ahead basis using customer-cited telemetry. So what that means in a practical sense is, say we have a customer that's installing a bunch of DC fast charging, right? And they are requesting 3 megawatts worth of power. Traditional utility planning is worst case scenario planning, right? So if there's a couple hours a year that go beyond that, that means that we would have to have the limit be at the top of that, right? But if we look at this at a dynamic hourly basis, we can instead set limits on a more real-time basis. So, in that hypothetical scenario of someone needing 3 megawatts of power for DC fast charging, with a solution like this, oftentimes we can provide that 3 megawatts 99% of the time, and then we dynamically manage around the hours where you can't, right? And that's using a technology to tell the customer's system how to manage against it. So This is essentially an evolution of, I mean, we've been issuing so-called load limit letters to customers for many years. When customers ask for service and we can't provide that whole service, that can be like a seasonal limit or other sorts of limits that are done via basically an analog version of what FlexConnect is now building out. But yeah, it's a bridge to wires solution at this point in time. It's a pilot currently. We're actively seeking customers to sign up for it or evaluate this. We're working this into our various customer programs and touch points we have with customers to have them consider it. I think pg.com/flexconnect will give more details about that if folks are curious.
Well, Eric, type that link in the chat. And Lisa has her hand up, and I'd certainly be interested to hear from, if any of our linear generator manufacturers have been discussing anything like this with your customers. But go ahead, Lisa.
Yeah, I just had a quick clarifying question for you, Eric. On this project that you're describing, is this non-residential or residential, and what are the qualifying factors for it?
It's primarily non-res, so economically it only makes sense right now for folks that are asking for a lot of power, just due to the customer investment needed for the telemetry pieces.
What's considered a lot of power?
Megawatts.
A megawatt, 1 megawatt?
Plural.
Megawatts, plural, but
plural. Okay, okay. Okay, well, I mean, and that's important to know, because those are completely different use cases, right, than the average fleet today. So I just kind of want to make a point there.
Danielle.
Yeah, and Eric can correct me if I'm wrong, but I just want to clarify that the flexible connection is a pilot specific to PG&E. This is not something currently being offered anywhere else, among the other utilities, at least not for SDG&E. So just want to caution that.
Thank you for that point of clarification.
Good point. Yeah, I think Edison has, there's differences, but there might be also piloting something similar.
They're from, I think, is it Maria? There was an Edison, I'm sorry, I don't know her name.
Maria.
Yeah, Maria, she may be able to speak to us, but I believe Edison, it's their local, the LCMS pilot, but that was also, I think, a single vendor pilot.
Thank you, Danielle. I'm actually from the generation side, so I don't have as many details on the load side, but we can follow up if needed on that. Leslie can send some information after this meeting.
Absolutely. I think we're going to probably move to our wrap up. We have 5 more minutes. Yes, while I'm calling on my team to do a recap, or actually basically asking our co-chairs and myself to just sort of think about the recap, I want to just kind of give people an update on our next steps. So our next infrastructure TRIG meeting is going to be, we're basically holding them on the second Monday afternoon of each month, except for November, because yeah, I forgot why. Oh, I think because it's a holiday usually. And I mentioned this earlier in my presentation, the very beginning, topics we should cover at future meetings. One of the things that just absolutely entered my brain was that need to have a very state and local government focused TRIG. And so that could involve other TRIG groups like outreach or rules or what's the other one? Border, I'm not sure. But I plan to circle back with the ACF team on something like this, because I know there's folks within CARB that have been thinking very, very specifically about state and local government fleets. Andrew, would you like to turn on your mic and chime in about what were your take homes from today? And then Lisa, Kate, if you have anything to add after Andrew, please do.
Definitely interested in hearing from the co-chairs. But yeah, I think this was a really great discussion. I think there's, we heard a lot of really good information today. I think it's apparent that there's a lot of interest and there's a lot of opportunity here with these devices and in being able to, you know, help us achieve all our common goals and trying to get to ZEV charging. But I think we are also highlighting where the gaps are really in our knowledge and where we need to move forward with these. And I'm really grateful to hear that South Coast is starting to address some of these, looking at these, especially through their rule, and hearing how the utilities are thinking about this technology and what it means to integrate these types of equipment at these locations. So yeah, I think we've had a lot of really good discussion. I think there is for sure a lot remaining to be discussed, and we still, I know, had a couple of questions that we weren't able to answer today. I know we've said it a lot of times, but on ACF, please do reach out to zevfleet@arb.ca.gov. And then on the low carbon fuel standard, they also have their email address. We're not the experts on the low carbon fuel standard, so I definitely encourage people to reach out to those staff on those questions. Do the chairs have anything they'd like to add?
I'll add. Yeah, I really enjoyed today's conversation. So thank you for all the presenters. This was really enlightening to just get the knowledge that there are solutions out there. You know, my takeaway is that I would love to understand the affordability side a little bit better in terms of whether it's for small fleets or large fleet, where that sweet spot is in terms of energy use, and how we in the regulatory system can continue to influence programs that are truly for the medium heavy duty. And instead of it being public, maybe it's a shared hub, like they've done in some of the programs I think that Energize did. Really coming up with definitions that bring a solution for the small fleet. I'm a little worried that some of this may not solve small fleets, which are largely a big part of the fleets that need to have a service. Funding. Everything's going to be about funding still, because we will be limited in terms of capacity for these solutions. So I'm sure there's the funding could probably make it more affordable. So those are my thoughts. Great presentations. Thank you so much.
Thanks, Lisa. And we have folks from the Energy Commission listening in, and we are certainly hearing that as well on the funding side. Just as a final parting note, and folks who are looking to buy trucks and looking for incentives within CARB to purchase trucks, I do understand that maybe, I'm not sure exactly when, but in the coming maybe 3 months or so, I'm not sure. Just please pay attention to the HVIP website. Sign up for HVIPs, you know, email listservs, just so you're getting notices about HVIP, CaliforniaHVIP.org, because they will be reopening with additional funding in the coming months. And I don't know much more about that, but it's definitely something that I'm aware of that's going to happen. There will be money soon. So that's all good news. And with that, thank you everybody for chiming in. Again, I've left my email on that website. You all know how to reach me. I definitely want to hear people's thoughts about what they want us to cover at future meetings. This was absolutely an excellent discussion today. So thank you.
Thank you.